Hello everyone and welcome to this playlist on vector algebra. So what we are going to be looking at is vectors. Okay, what are vectors? That's what we are going to be looking at throughout this series, and this is the first video we have on this series. Okay, so in this video we are going to be looking at the definition of vectors, and then we'll look at a simple representation and possibly some different types of vectors. That's what we are going to be looking at in this video. So what we actually called a vector? What's a vector? Now when it comes to physical quantities, there are two classes of physical quantities if you want to classify them. We say we have the vector quantities, and then we also have the scalar quantities. Now scalar quantities are quantities that have just magnitude, okay, something like speeds. Another example is something like distance, okay, length, temperature. These are scalar quantities because you can only represent them in terms of magnitude. They don't have direction. But when it comes to vector quantities have both magnitude and direction. Some books will go ahead to say they have magnitude, direction, and also what we call orientation in space. That's what a vector quantity is. Now if you want to sum scalar quantities, it's quite simple. You just go ahead and add them, do your normal math. 5 plus 7, that will give us 12. 30 plus 40, that will give us 70. That's for scalar quantities. But when it comes to vector quantities, it's not as simple as that. Okay, so amount of geometry is involved. In some cases, a little bit of algebra is also a great deal, not even a little bit, a great deal of algebra is also involved. So the first thing we have to look at is how do we represent a vector. Now when it comes to printed formats, we usually represent a vector with a line segment, and then when it comes to written format, we can represent a vector with something of this nature. So this is what I have this vector, okay. Hold on. So this is a vector. You can see we have a directed line segment. This directed line segment makes it obvious that this is having a direction. Okay, now this is the direction. Then what about the magnitude? We say the magnitude is equivalent to the length of the vector. So you can see what we use to represent this vector here. We use a written letter, a capital letter with an arrow overhead. You can also look at this vector. That's another example. Look at these vectors you have it. This is another vector we have. Now we are looking at these two vectors, this and this. We would say this magnitude, the magnitude of this vector is larger than the magnitude of this vector. When we look at the magnitude, we are talking about what is the length, okay? What is the length that is occupied by this vector? That's what we mean by the magnitude. So since this arrow is longer than this, we can easily say in printed format that this vector is larger than this in terms of magnitude. So look at what I have: a vector with an arrow overhead, a vector with an arrow overhead. Now don't mind the fact that I'm using capital letter. You can also use small letter. You can say I have A with an arrow overhead, or I have Q with an arrow overhead. These are also good representation of vectors. Then apart from using a single letter, you can also use a combination of two letters to represent a vector. For example, look at this one we have here. We have the starting point, which is P. We have the end point, which is Q. For the fact that it starts from P to Q, we say this vector is PQ. Similarly, if you have a vector that starts from a point A down to a point C, then we can say this vector is AC. Okay, then you just put the arrow overhead to show that that's actually a vector. Now that doesn't mean if you have something with an arrow without having an arrow overhead that is not a vector. That's not the case. It depends on the representation. Okay, some person will just give you a vector like this. They will just say, okay, this I have here is a vector. For the fact that it's been defined as a vector, then you take it as a vector. Okay, but in formal notation, there must be an arrow overhead for it to be a vector. So here I have A to C, and I have this arrow to show that it starts from A. Now this A here, this A and C, they are called the end point. This is the initial point, and this is the terminal point. Okay, so here the initial point is P, the terminal point is Q. So that's the vector PQ. So we have three basic representations. We can use capital letter with a single case, capital letter, small letter with a single case, and then capital letter with two cases. You can also have small letter with two cases and the rest of that. That's for the definition of a vector. I hope this is clear. Next, we are going to look at different types of vectors. Okay, when you talk about different types of vectors, when it comes to scalar quantities, one good example of a scalar quantity, like I've explained initially, is temperature. You have something like distance. You have volume. These are scalar quantities. But when it comes to vector quantities, good examples we have, they are displacements. Okay, we have velocity, is also a scalar quantity. We have force. Sorry, these are vector quantities. Sorry about that. We have weight. Weight is another type of force, but I just decided to bring it out. It's also a vector quantity. We have momentum. So be it linear momentum or angular momentum, they are both vector quantities. We have current density. We have acceleration. Okay, electric field, and then we have torque. These are all vector quantities. Okay, so that's what we have, guys, for this video. I hope you enjoyed the video. If you have any question, go ahead and put it in the comment section below, or if you can reach out to me, go ahead and reach out to me and ask your questions. Okay, so I'll see you guys in the next video, where we're going to be talking about different types of vectors. That's what we'll have in the next video. Okay, I'll see you guys then. Bye bye.